Hello beautiful people, welcome to today's lecture. Today we'll be looking at urinalysis. Urinalysis is simply the analysis of urine. When you talk about urinalysis comprises of the physical, chemical, and microscopic examination of urine samples. This is clinical chemistry laboratory, and so we're going to be looking at the chemical analysis of urine. To do chemical analysis of urine, the simplest way we use nowadays is the use of urinalysis strip. Urinalysis strip simply consists of a plastic strip on which chemicals has been embedded. The first part of this lecture talked about the theoretical aspect of this, giving us a breakdown of the 9 parameters. This is Combi 9, and we call it Combi 9 because there are 9 different analytes that this particular strip can detect. There is Combi 2, there is Combi 1. Okay, there's one that is just 1. The one that is just 1 is for glucose estimation. The one that is just 2 is glucose and protein. But this one has 9 parameters. So there are 9 different parameters. If you've not seen the first part of this video, please, I would advise that you go back and watch that, because that will give you a clear indication of what we are doing here. There are different companies that produce this urinalysis strip, and when you start working, you'll be able to get used to the arrangement of the 9 parameters and their color coding. Now, this particular one I'm using is from Ako answer. Okay, 1 2 3 4 5 6 7 8 9. I believe you can see this. This is the container. It comes with this chart, and it comes with a chart, and this chart helps you to take your reading. These are the 9 parameters, starting with nitrite down to ascorbic acid. This particular company added seconds. Like the first one is 60, because they say test and reading time. This gives you an idea: 60 seconds, 60 seconds, 45 seconds. This gives you an idea of which one reacts first. And so in 45 seconds, you should be able to start reading these ones. So it's advisable to read from down to up. That's the way they arranged it. Now, one thing you need to take note of when you look at this particular urinalysis kit is that the very first line, this particular line, represents the normal. That is the color that the test strip comes with. Any deviation from this color now shows the presence of the particular analyte. This strip comes with a cover, well stoppered, like tightly stoppered. That is for a reason. It is meant to protect the strips inside here from atmospheric moisture, because moisture from the atmosphere can get into the strip and cause it to get discolored and get damaged. So each time you want to use this, when you open, you collect the strip, the one you want to use, and then you replace it immediately. Now watch this. These are the parts that have been embedded with chemicals. So if you watch, you see that there are chemicals embedded, okay, on this strip. This part is vacant. This is where you hold it. Do not touch this part, because when you touch it, you will contaminate it, and you will be heading towards wrong results. So if you check, this is how you hold it vertical. You see that the color at this point correspond with this first line at this point. Okay, whenever you check and the color here does not correspond with this first line, you know that there's discoloration or decoloration. Therefore, you don't go ahead and use it. Okay, once that has been ascertained, you go ahead. How do we carry out the test result? Just watch me and see what I'll do. Take a freshly voided urine and mix it by gentle inversion several times. You have to dip the urine, making sure that all this area with chemicals enter the urine. And when you dip it, you don't leave it inside the urine for too long. Just dip it 1 second and bring it out. And then you take your reading within 60 seconds. Anything beyond 2 minutes, 120 seconds. Please don't take any reading. Within 60 seconds of dipping this, you take your reading. So after you've mixed the urine sample, you dip, making sure that every part touch. Then you remove the excess. You see what I did? You remove the excess by running this across the rim of the container. That is to remove the excess urine. And once you have dipped this into the urine, you do not hold this strip vertically. You can see how I'm holding it horizontally, because by the time you hold it vertically, the fluid will seep into the next one, and it will be difficult for you to interpret the results. Once you are done, you can place it on an absorbent paper like this to remove the excess. Okay, then once you are done, within 60 seconds, you can have a stopwatch by your side. But even without a stopwatch, you can count 60 seconds in your mind. And then you start taking your reading. So what to do is to match or to compare the color and see if there's any change from this first one. Let's take it one by one. The first one is nitrite, which was white. It remained white. There is no change. The second one is urobilinogen, which was pinkish. It remained pinkish. There is no change. That means there's no nitrite, there's no urobilinogen. The next one is protein. It was light green, greenish yellow. But now look at the transition. You see where it matches? Matches this, which is 2 plus. They give you the grading: negative, trace, 1 plus, 2 plus. So which one does it correspond with? To me, it corresponds with 2 plus. And that is why you must take this reading under a bright light. So you quickly note protein 2 plus. Okay? You go ahead and check the next one, pH. pH, there must be a reaction. So you check which one does it correspond with? It corresponds with 6.0, which is the normal pH of urine, which is what? Slightly acidic. So pH is 6.0. Now, the next one is blood. Blood remained yellow, pinkish yellow. So there's no change. Ketone is still here. There's no change. Bilirubin is here. There's no change. Glucose. There was a change in glucose. I would give it 1 plus. I would give glucose 1 plus. It's heading towards 2 plus, but I'll give it 1 plus. So glucose 1 plus. The last thing here is ascorbic acid. You can see that ascorbic acid, there was absolutely no change. There was no change. It remained bluish green. So I will give ascorbic acid nil. So that is it. That's how you carry out your urinalysis test. You can now discard the strip. So how do you report it? First of all, you say that pH is 6.0. Protein and glucose is present. Others, nil. That's how we report it. Then you can now go ahead, depending on the way the request form is, you can now go ahead and put the level, whether it's 1 plus, 2 plus, or 3 pluses.
Okay, so this is a closer look at the urinalysis chart or the container of the urinalysis strip. We call it dipstick. So if you look, there are 9 parameters here. This is for combinine. Okay, and if you check, there are color difference. There are color grades for each analyte. There are different color grades. Looking closer at it, you can see that the very first one here is nitrite, and the first box there writes negative, followed by positive. All right, any degree of pink color. So if the pink color changes, that tells you the grade of the presence. So if it's either it is 1 plus, you can see some of them have numbers, and then some of them have 1 plus, 2 plus, 3 plus, and the rest. So this test is quite simple. Once you open up this, you collect the strip, the one you collect the one you want to use, and then you cover it back very well. Cover it very well. This is the strip. You hold it by the part where there is no chemical, and if you check, when you match this strip with the first line, you see that it corresponds with the first line, right? It corresponds with the first line. And once that is ascertained, it means it's good, and then you can use it. And then when you dip it into the urine, all you do is to match and then check the color that corresponds with, if there's any color change. So it's about dip and match, dip and match, dip and match. It's that simple. All right.
Thank you for listening. As I said, if you didn't watch the first part of this video, which gives us a theoretical background to this, please do well to watch that video to understand the clinical significance of each of these. That is what their presence in urine signifies.